The following video covers the operation and features of the Program tab for the NORAD 2-line element program tracking tool. Look for our separate videos that cover the Fix tab and the List tab. First, a brief overview. The Program tab allows you to upload and store NORAD 2-line element sets to recall and track satellites. In this video, we will cover uploading satellites using the Upload button, Program Track Setting using the Settings button, and finally, the Sun Track using the Sun button. Let's start with uploading a TLE file using the Upload button. After pressing this button, the Program Track Upload window will appear. Before we upload files, let's go over the Options and File Format features. The Options allows the user to select what is done with any current uploaded TLE files. The user can select to delete all before upload or the Always Overwrite checkbox. This will ensure that the operator uses the most recent TLE file and will eliminate the chance of using any older or out-of-date TLE file. The file format allows the user to select 3-line or 2-line file uploads. 2-line will upload the data only, while 3-line will carry the spacecraft name along with the 2-line element set. For this demonstration, we will select Always Overwrite for options and then 3-line for file format. Under the File Upload heading, left-click anywhere over the gray box with the label Choose TLE File. This will launch your computer's file browser window to search your computer for the pre-stored text file created. Once you've selected a file, the contents of this file will be displayed in the Contents field. Each entry is defined by 3 lines. The red line is the satellite name, the blue line is the first line of the orbital elements, and the green line is the second line of the orbital elements. Each additional set should follow this format for a successful file upload. Once the files have been uploaded, the files will be displayed as individual entries in the Program Track database. The scroll bar at the right of the database allows you to scroll through all of the entries. To select an entry to track, double-click over the satellite of interest. The positioner will move to the target. If the satellite is not visible yet, the positioner will travel to the azimuth heading for arrival at the horizon and wait to start the track until the satellite is visible above the horizon. Now, let's cover the constellation mode. The Program Track window works in conjunction with the Constellation tool. This tool allows you to schedule multiple satellite passes, prioritize them, and provides a visualization of the satellites you are tracking. To switch to the Constellation tool, select the View button at the top right of the control window. A pop-up window will appear, and you will hit Constellation. The Constellation window has a drop-down configuration tool to place satellites into a scheduler and build an automated list of satellites to track over time. The features of the Constellation tool will be covered in a separate video. Please look out for our Constellation mode video for more details on this tool. We will now cover the Settings button under the Program tab. This button will open the Program Track Settings window. There are 3 fields for user setup and operation for Program Track. Let's discuss the offsets first. The Offsets field allows a user to view or add azimuth or elevation offset in units of degrees. If offsets have been applied, they will be displayed here. If set to 0, there are no offsets currently applied. If you wish to add offsets, the fields can be edited. There are also other ways to apply offsets while actively tracking, which we will discuss later on in this video. The time offset is in seconds. The positioner can use the onboard GPS time or Network Time Protocol, NTP, to sync the time. If it is believed that the timing may be inaccurate, this allows the user to move the system forward or backwards from the current system time. The elevation entry and exit thresholds allow the user to decide when the Nextmove positioner will start and stop tracking satellites. Certain site installations may not allow a user to track a satellite to the horizon. A tree line, a building, or another blockage may limit the overall full sky visibility. For example, an operator may select an entry and exit threshold of 10, which would equal 10 degrees elevation. This would force the system to start tracking the next satellite pass at 10 degrees above the horizon and finish tracking to move to the next satellite at 10 degrees above the horizon. Lastly, we will go over the LOS behavior in the Program Track Settings window. The LOS behavior, which is abbreviated and stands for Loss of Satellite Behavior, provides the user with 3 different options. The user may select for the system to go into standby mode, stow the positioner, or pre-position for the next track. If standby is selected, the positioner will disengage its drives and go into standby mode until the next satellite pass becomes visible. If stow is selected, the positioner will go to the pre-configured stow position, which is typically 0 degrees azimuth and 90 degrees elevation, and wait until the next pass becomes visible before moving again. If preposition is selected, the positioner will go to the arrival of the satellite for the next pass and wait for the satellite to rise and start tracking. If there is no wait time between passes, the LOS behavior is defaulted to track the next visible satellite. Now, let's discuss the Sun Track tool. This button is only active when a GPS and heading override are also active. This is indicated by both the GPS local coordinate status LED and the heading source LED are blue, as shown here. A green light on one or both means the sensors are active and SunTrack is inactive. The error associated with both of these devices creates dynamic offsets which are difficult to control. Therefore, a one-time static lat/long and heading will create the best result when using the Program Track tool. Let's click on the sun and observe the positioner move over the polar plot window and track the sun. A quick note, the sun must be visible when using this tool and it will not work if the sun is set. This tool is also not very useful if your system is inside a building or if it's a very cloudy day. When the positioner is in Program Track mode, the manual controls window switches to ephemeris track offsets. This tool now lets the user dynamically update offsets to remove system error. These offsets will match the offsets under the Program Track settings button previously discussed. As shown, here they are currently set to 0.00 in both azimuth and elevation. The Sun Track is typically only used once on setup of a new system. The operator may now select a step size and visually align the antenna. For example, if the antenna is prime focus, the operator will be looking to apply offsets until the feed shadow is centered in the antenna's reflector. If the feed type is Cassegrain, the operator will be looking to apply offsets until the feed is fully illuminated by the sun and no shadow is present. This concludes the operation and features of the Program tab for the NORAD 2-line element program tracking tool. Thanks for watching!